So I want to show you an option for finding volumes of revolution. So this method is called the shell method. So it is similar to the disk washer method in that we're going to find an expression for this little chunk of volume and then we're going to add them up. So this time, instead of having like a flat washer that we stack up, we're going to have these thin cylinders that we build around. So you can sort of think of the layers of an onion, right, making up a solid. So we want to find a formula, an expression for each of those little layers of the onion. So we're going to use right circular cylinders, and our little chunk of volume is going to be equal to the surface area of the cylinder times its thickness. So I need an equation, a relationship for the surface area of the cylinder. And so the way that you do that is you imagine, right, taking a cylinder, cutting it down. Here I've got a little visual. So I have a cylinder, right, and then we cut it down a side and we lay it flat. And it turns out that the surface area is the same as the area of a rectangle, which is very handy. So we need the area of a rectangle. Okay. And I'm going to label this side an H. I'm getting myself set up. And then across here, right, think about the cylinder, right? That's the same thing as the circumference around the top. So this is 2 pi r. So I want to take a look real quick at my picture. So notice I've drawn in an axis of rotation, right? So when we're doing our volumes of revolution, we're rotating around an axis. And r, that r that we're finding, that is the distance from the axis of rotation. You will hear me say that every single time for both the shell method and for the disk and washer method. It's my go-to. R is our distance from the axis of rotation. And then H, right, that's just the height of the rectangle. And then our thickness will be either a dx or a dy. So altogether then, our total volume, so remember we're going to find all of these. These are our little dv's, and then we're going to add them all up. So we are going to add up, well here, let's do here. So our cross-sectional area is 2 pi RH, right? And then we have our little thickness, our d, whatever that's going to be. So I'll write it with a dx. So our volume formula then, 2 pi is a constant, so it can live out front. So 2 pi RH dx. And then we'll need our limits of integration from a to b. So we're going to walk through one nice example. And so for each of these, I'm going to have a little guideline here where I write down all the things that I need to find. So I need to know my thickness. I need to know a and b, my limits of integration. I need to know how far my rectangle is from the axis of rotation. And I need to know my h. And I don't know if you saw this or not, but for the shell method, our rectangles that we're going to draw are parallel to the axis of rotation. So shell method, the two L's, parallel to the axis of rotation. Okay, so we're going to take the equation y equals 9 minus x squared in quadrant 1. So I have it sketched here, and we're going to spin that around the y-axis and make a solid. So I'm going to draw my rectangle parallel to the axis of rotation. Okay. So once you get the rectangle in, I use that to come up with the values, right, for my little guideline here. So my thickness, right, that's the little dimension. So that's going to be a dx. So my limits, since I'm integrating with respect to x, I need these x values. So where do my x's start and stop here? Right? Well, they start at x equals 0, and they end at the x-intercept over here, so 3. R is my distance that my rectangle is from the axis I'm spinning about. So I'm spinning about the y-axis, so that means my distance is the x value, right? This amount here is whatever the x value is. So that's what I'll put in for my r. And then my h, that's the y value. But, right, I'm integrating with respect to x, so I don't want to have a y here. I want the x version of this. And that y is the same thing as 9 minus x squared. Okay. So I know everything I need for my formula. So I'm going to go ahead and write out my volume. 2 pi integrating between 0 and 3, r, which is x, times h, which is 9 minus x squared, dx. Okay. So for shell method, there's always this little piece of algebra that comes first. I was just noticing you could actually do a u sub if you wanted, but the algebra way is certainly easier in my opinion. So we'll distribute the x, and now we'll go ahead and find our antiderivative. So 9x squared over 2 minus x to the 4th over 4 between 0 and 3. So that will be 2 pi times, what is that, 81 halves minus 81 fourths minus 0, right? The 0 goes away, so I don't need that. And let's see. Okay, so I'm going to do some fancy algebra, and I'm just going to write down my answer here. So 2 pi times 81 fourths. So 162, oh, ha ha ha, I can do it even better, right? 81 pi halves.